Hello everyone. So today we'll do one question based on limits. So this is the setup of the question, and your goal is to find the value of alpha and beta. So if you want to cook this question, I'll be sharing three different recipes with you. Each recipe is equally important. So to solve using recipe one, if you're aware about these two standard results, so I'll be writing the prerequisite for this. If you are aware about limit x tending to 0 sin x by x, your answer is in your mind. And the second is limit x tending to 0 1 minus cos x by x square. If you know the direct result, this is 1 and this is 1 over 2. So using these two direct result, you can solve this question. So you can pause the video and try the question with the ingredients of recipe 1. Okay, yeah. So if you are done trying, so if you want to solve this question, in the question you can see there is sin x over x. You can generate somehow if you divide it. There is no 1 minus cos x. You only have cos x lying alone. So what manipulation you can do here? So the same question we can write down, limit x tending to 0 alpha into 1 minus x sin x plus beta times of cos x. You want cos x 1 minus cos x, or if you drag minus common from the numerator, it's cos x minus 1, right? So I can write down this as cos x minus 1 and plus 1 to balance it out, plus 5 divided by x square is 3. So then this goes to limit x tending to 0. We are starting our manipulation journey. First you multiply alpha minus alpha into x into sin x plus beta into, let cos x minus 1 is in one bracket. I hope you get it. Why? Because we want to use this 1 minus cos x. So I have not played much with that. Divided by x square, and on the right hand side you have this is equal to 3. So this is limit extending to 0. Bring all the constant to one side. So you have alpha plus beta plus 5. One bucket minus alpha into x into sin x. Another bucket. And I'm taking minus common so that I can write beta into 1 minus cos x. Because somehow I need to generate this, right? Now we will separate and divide by x square. What is in the denominator? I'm distributing to all three. Divided by x square, and this is equal to 3. Now this is limit x tending to 0. Now if you observe the question, x and x can get cancelled. Sin x by x is 1. 1 minus cos x by x square, direct result is 1 over 2. The only problem is the moment you put 0 here, the numerator is a constant, and whether you go for 0 plus or 0 minus, the answer will shoot to infinity. But you want a finite answer which is 3. So what you should do here so that you can reach to finite answer, because x square in the denominator will always make a problem, right? Now when you talk about limits, you are doing 0 plus or 0 minus in the denominator. So you would want the numerator to be exactly 0, because exact 0 by tending 0 values will be 0. So you are able to figure it out. One info from here, which is alpha plus beta plus 5 should be 0, because unless you set up this to 0, the denominator will always irritate you, because this will take the answer to infinity and you want the answer to go to a finite number, right? So this is the first block. So this is when you're putting this, so this becomes 0 minus, I'm simultaneously applying the limit, so I'm removing from here. Now when you're planning to apply the limit, so here one x can be cancelled, and this is alpha times of sin x by x, limiting value is 1. I'm not writing all those again. And 1 minus cos x by x square, limit is outside, that is half, minus beta by 2 is 3. So you are getting one equation, minus alpha minus beta by 2 is 3 from this bucket. So two equations are ready. We got one as this, and the other equation was minus alpha minus beta by 2, bring minus 3 to left side, equal to 0. Add both the equations, so beta minus beta by 2, so beta by 2 and plus 2 equal to 0. So the value of beta is minus 4. This value you drop here and you will get the value of beta is minus 4. So alpha is minus 1. Okay, so this is how you solve the question using recipe 1, or basically you have cooked the question using recipe 1 where you're using these two info. Now we'll try to solve the question or cook the question with our second recipe. So if I want to use recipe 2, so the ingredient for recipe 2 would be the expansion logic. Expansions. Each recipe is equally important, right? So the expansion of sin x is x minus x cube by 3 factorial, which is 6, and so on. The expansion of cos x is cos 0 is 1, so it will start with 1, 1 minus x square by 2 factorial, and so on. You can write down more number of terms, but the idea is whenever you are solving a question using expansion, you will write down the expansion only till the highest power of denominator. So highest power of denominator is going till 2. So now if you start cooking the question using these two ideas, so it looks like limit x tending to 0, alpha into 1 minus x multiplied with, now sin x expansion, if you write till x cube, the moment x is multiplied with x cube, it will go till x power 4. You need till x square, so you should only replace with what? Only x. So I'm only replacing it with x. I hope you know the reason. If you're not aware, you can type it in the comment. I'll try explaining why we do that. Now cos x you'll write down only till 1 minus x square by 2 plus 5 divided by x square is 3. So the setup is limit x tending to 0. Take all the constant to one side, alpha plus beta plus 5. Take x square common, minus alpha minus beta by 2, and divide by x square on both the terms, which is 3. Now I think you realize we are in the same page. Same page as in, if you go to the previous recipe, you got this term and what we were talking here. The moment you do 0 plus or 0 minus, this will go to infinity because this is a constant. So we equated this exactly to 0. Same story, man. So again, you're getting to the same logic. The answer is a finite quantity. And on top of this x square, you can remove it from here. So again, what you're reaching? You're reaching the same destination. So alpha plus beta plus 5 should be 0. And if you have applied the limit, so it's like I have removed the limit now, okay? So if I have removed the limit, you're getting minus alpha minus beta by 2 equal to 3. So minus alpha minus beta by 2, bring 3 to left side, minus 3 equal to 0. Now if you see same profile picture, alpha plus beta plus 5 is 0, minus alpha minus beta minus 3, is it? Same profile. So again you will add this, so on adding you'll get beta equal to minus 4 and we got alpha equal to minus 1, which was your same answer, okay? So this is how we have cooked the question with recipe 2. Now we will try to cook this with recipe 3. So the ingredients which you need to know for recipe 3 is your L'Hopital or L hospital rule. So L hospital rule is whenever the limit is of the form 0 by 0 or infinity by infinity, you can differentiate the numerator and denominator simultaneously. So I'm assuming you know this rule. So how to apply it here? Step number 1, if I want to use L'Hopital, I need to ensure this is in 0 by 0 or infinity by infinity format. Now, if you put 0 here, what is happening? If you put 0 here, if you try to put the value of limit here and try to see, because that's our step number 1 to evaluate. So you'll get alpha into 1 minus 0 plus beta plus 5 by 0 equal to 3. Now again your numerator is becoming a constant, right? If you observe, your numerator is constant. Alpha plus beta plus 5 by 0 is 3, suppose. And you're evaluating the limit. If you're evaluating the limit and it is a finite quantity, which means there should be some indeterminacy. If you see 0 in the denominator, the indeterminacy with 0 is 0 by 0 format. So again, one equation is directly ready, which is alpha plus beta plus 5 is 0. This is your first equation. Or some people will tell like fake method kind of, you'll throw x square to that side and apply limit on this side. But this is the idea, actual idea behind it. So that is one equation. Now if you know this, you are eligible for L'Hopital rule. So if I apply L'Hopital rule, limit x tending to 0, alpha into derivative of 1 is 0, product rule, minus x into derivative of sin x is cos x, and minus derivative of x is 1, minus x cos x, and then derivative of x is 1 into sin x, and derivative of cos x is minus sin x. Derivative of 5 is 0, and divided by 2x is 3. So you are at limit x tending to 0, alpha times of this 2x I'm dropping here, okay? So minus x into cos x by 2x minus sin x by 2x minus beta sin x by 2x, and that's equal to 3. Now you can apply the limit, no worries. Alpha times of, if you applied the limit, x is getting cancelled, cos 0 is 1, minus 1 by 2, sin x by x is 1, again minus 1 by 2, sin x by x is 1, minus beta by 2 equal to 3. So if you simplify, you are going to get minus alpha minus beta by 2 equal to 3. Or if you see the previous two slides or the previous two recipe, this is what we were getting. Same equation, solve, bang bang, value of beta minus 4, value of alpha minus 1. There you go. Okay. So this is how you can cook this question with 3 different methods. All the methods are equally important. Your recipe 1 is using this fact, some question this is useful, and you're learning a good manipulation technique here. Your second recipe would be to use the expansion. Key takeaways: whenever you're using the expansion, you need to expand till the highest power of denominator. If unaware, you can let me know. We'll see if I can help you out with that. And your recipe number 3 is using L'Hopital rule, where you're hitting 0 by 0. Thank you. Hope you liked the video. In case you have more doubts, feel free to put it in the comment. I'll try to make the videos possible as soon as possible. Yeah. Thank you. Bye.